To help picture what's going on with proof of work, let's walk through a simple demonstration. For this, we'll head back over to the website anders.com. We provided a link to the site down below the video. Here, we'll quickly go over what a nonce is, how it relates to block difficulty, and why block difficulty is even important. These are all related to helping understand proof of work and how it relates to the speed and security of the network. To start, we'll add in some transaction information ourselves. This can be anything, so feel free to add in your own if you'd like. For mine, I'll say I send Brandy 3 Bitcoin, then Brandy sends 2 Bitcoin to Jessica. These aren't real transactions, just made them up. This gives us an unvalidated block that we need to find a hash for. Instead of clicking mine, focus on this number right here. This is the nonce. This is the number the computer is trying to figure out to solve the problem needed for the proof of work algorithm. But you don't need a computer for this. It's just a lot faster if you have one. Try it for yourself. Change the nonce until the output has one leading 0. Whoa, cool. Looks like I got pretty lucky there. The problem is I don't need 1 0, I need 4, and that can take a lot longer. This guessing over and over can get extremely tedious, but it's the only way to solve this problem. This manual random guessing and checking is exactly what the mining computers are doing. The more leading zeros we need, the longer it will take to find the answer. That's because wanting a hash with more zeros is a more specific request. That makes it less likely that you'll find a solution and results in way more guessing. This number of leading zeros requested is what we refer to as the block difficulty. This block difficulty can be changed by updating the algorithm to ask for more or less zeros. You might change the difficulty anytime you want the computers to be able to solve the algorithm slower or faster. In Bitcoin, they adjust the difficulty automatically to help ensure a new block is created every 10 minutes. If blocks are created too fast, they'll increase the difficulty to slow the process down. But if they're being made too slow, they'll decrease the difficulty to make the process faster. You might wonder, why is 10 minutes important? Having a block every 10 minutes was a decision made by the developers. This 10-minute time was considered a good balance between having a secure network and a network that can actually keep up with creating new blocks. For example, if a block was created once every hour, the amount of transactions waiting to be verified would increase drastically and the network would be too slow. But on the other hand, if a block could be made every second, then it might allow a hacker the opportunity to change data and remine the blocks before the network could catch the attack. And that's just a quick summary of why 10 minutes is considered important. This decision can change for different networks depending on what the developers happen to find important. So that wraps up this quick demo on proof of work. Hopefully now you have a better understanding of how it all works. Coming up, we'll look at some of the issues with this system, then look at a few other algorithms that could potentially provide a solution.